Now we've learned the basics of the template fundamentals, we're actually going to look at some Angular directives and some expression transformation using pipes in this next section. So in this first video, we are going to look at something called an ngIf. Now you've probably seen an ngIf out in the wild, or at least the concept of showing or hiding something based on a particular expression. So let's imagine I have a drop-down menu that's JavaScript driven. I click on that, it then expands. So this is typically a show and a hide behavior based on a particular expression. So this is something that we could use an ngIf for. So in this lesson, we are essentially going to use this input to use an ngIf inside a particular div to say that we're searching for a particular name once the name has a length property. And you may have seen this if you browse Google, and it tries to auto suggest things for you as you are typing into the search results. So one small thing here is that instead of passing just event, I've actually passed event.target.value. So instead of actually doing this in the actual component here and doing event.target.value, you can actually move it up into here. So I'm just demonstrating another concept of Angular and how flexible the template syntaxes are. Right, so let's get started with an ngIf. So let's assume that we want to create this div and only show it when the user has typed something in. So we can create some text in here saying searching for ... and then name. So we're initializing it with a value of Todd. We're going to create this as an empty string. Now an ngIf starts with an asterisk or a star if you want to call it that, and then we type ng and then if. So you can see here that we're using a Angular directive. So this is our first directive. So this is what we call a structural directive, because like we saw in the architecture video right at the beginning of this course, we can add directives to particular components or their templates. So we use this asterisk, and I'll explain why and actually show you the code that it generates under the hood so we can understand why Angular does this. So at the moment we've gotten rid of our forms module and we're using this value and we're binding the name. As soon as an input event happens, we're firing this handle change, we're passing the event.target.value down, and then we're reassigning this.name. So up here in this component, we have an ngIf. So we only want to show this div if the name actually has a length. And that's exactly what we can pass in. So we can do name.length. So when we actually start typing, because we're initializing it with an empty value, we won't actually see searching for ... However, when we start typing and it has a length, we can then start seeing this searching for, and you can imagine that this is used as some kind of search result or a type ahead. So over here in the browser, we have our input, and I go ahead and start typing top motto. So it says searching for top motto, and if I delete the whole thing, you can't see the searching for. So the ngIf is an easy toggle to display and hide content based on a particular condition. We can also add some more expressions. So we can say if the name.length is greater than 2. So let's go and try this out. So we can do T, O, D, and then it starts actually showing. So this gives you an example of the template expressions that you can actually bind in line to Angular's templates. So the next stage is actually understanding this asterisk, and this is actually really important. If you want to look at this in your spare time, you can do. It's not in the scope of the course because web components is an entirely new concept to the DOM. But essentially, web components has a specification where it has a template element. And you can go and try this yourself in plain HTML and JavaScript and look at the template element and the web component specification. So Angular basically sits on top of the web platform, meaning we can use things like Shadow DOM. So this template allows us to essentially create a particular template that Angular can then use to generate content from. So if you imagine we had this div, all this is doing is really putting the div inside a template, and then the asterisk can completely disappear, and we can take this ngIf and the name.length, and we can leave the div like this. So if you imagine that the template is a web component piece of HTML that could be used as a template elsewhere, or it can be used multiple times. And the asterisk here is simply sugar syntax for not having to type the word template yourself. So all this is really doing is square brackets and then ngIf, because we're using a property binding to evaluate the ngIf expression. and then it's going to do this name.length is greater than 2. So the actual check is on the template itself. So this is why you do not see the ngIf in the DOM if you wanted to inspect elements. So you just see the actual div itself. So this is the difference between using something like a property binding. So the template, it's actually using the property binding. However, here is just sugar syntax, so we don't have to write these template elements ourselves. Now, when we come onto the Pro course, we'll be talking about component encapsulation and Shadow DOM much further, which takes these concepts to the next level and shows you more of the power that Angular actually gives us via their web components. So let's dive across to the browser and we'll actually check both of these out because both of them will actually work identically. So as before, we can do 1, 2, and then on the third letter, you can see that both of the ngIfs have actually kicked in. We have the first one, which is using the template element, and the second one, which is using the sugar syntax with the asterisk. So that's how to use ngIf. You can pass it an expression, and it can evaluate based on that expression. It can either be a Boolean or evaluate to a truthy or a falsy value inside Angular. In this next video, we are going to look at something called ng4. Now, ng4 also uses an asterisk like we saw with ngIf, so you can assume that we're already going to be using some form of template that may be used or repeated. So let's have a walk through this code really quickly. Now, I'm going to create some form of airline passengers list, and we're going to use ng4 to iterate over these passengers and basically print them out one by one using our template inside a list. Now, the interesting thing is we have a public property called passengers. So instantly we can access the passengers and we could do something like passengers.length, which will give us the array length in the actual template. One thing that we're going to do is introduce you to some more TypeScript. So you can see I have this word any. Now, if I remove this, TypeScript actually complains at me because it expects a type. I could get rid of this by doing this. However, we want to do things properly. So we're going to create a type called passenger, which essentially matches the keys of each of these objects. Now, obviously, this is an array of passengers, so it's going to be passenger array. It's underlined in red because it cannot find the name of passenger. So what we're going to do first is actually create an interface based off of these. So each passenger has an ID, a full name, and they are checked in, true or false. For instance, this one's false. True, true, and false, and each of them has a unique ID. So to do this and create our own type, we essentially create something called an interface. So we can do interface and then passenger, and this is basically a virtual object that describes what these passengers look like. Now, each of them has an ID, a full name, which is a string, the ID is a number, checked in is then a Boolean. So we can go up here and say ID is going to be a number, full name is going to be a string, and then the checked in is going to be a Boolean. So this is essentially a descriptor of our object, and you can see that there are no red underlines here. However, if we converted this to perhaps a string, you would see this big red underline, and it would give us an error message saying that the string is not actually of the correct type. So TypeScript is really helpful when we're actually dealing with data sets such as passengers and an array. So here's our first interface. If you haven't used TypeScript before, we've got an ID, full name checked in. We can add another property to this, such we'll just call it prop and we'll call it false. And you can see that this is now red underlined because this doesn't exist in our interface. So these are really good for handling and managing your data. So the first thing we want to do is actually list our airline passengers out. So to do this, what we'll do is create a unordered list. Now inside this list, we're going to create an li, and then we're going to close it off. Now already you can start to imagine that we're going to render out our passengers somewhere in here. So we want to create a list item with Angular for every single passenger. Now again, we want to treat this as a template element like we saw in the ngIf video. So what we do is ng4 with the asterisk. And now what we do is do let, so this creates a local variable called passenger. So we do let passenger, and then we do of passengers. Now this might look familiar to you if you've been using JavaScript. So this is basically a for of loop. So essentially inside of here, we have access to each individual passenger. So we could in fact wrap this inside a curly brace, and we can quickly go and check this out in the browser. So you can see that we have airline passengers. We obviously have 5 passengers in our flight today, and we have all 5 objects that have been printed out to the DOM. Now obviously we want to display the individual keys, so let's go back and actually make this work properly with the ng4. So looking back at our passengers array, we have an ID, a full name, and checked in or true or false. So what we're going to do is just simply do .fullName. So this is just looking up the object property on that particular passenger. When we go back to the browser, you can see that all of our names have been rendered out correctly. Now, sometimes we might want to create some kind of click event inside of here where we want to know the particular index of the person. So let's assume that we want to put the index here and actually just list out in numerical order the index of the passenger. So obviously this is an array, so the index is going to start from 0, so we'll have 0, 1, 2, 3, 4 in our passengers. The way that we can get the index is by creating another variable here. So we can do let I, which the I corresponds to this one. We can call it whatever we want, and we just do equals index. So index is exposed to us via Angular, and we can call it I. So we're just simply referencing this variable locally, and inside the template, we then pick up this I. So let's go and have a look at this. And there you go, you can see that we have 0, 1, 2, 3, 4. Just like before with the ngIf video, we're going to show how this expands to a template element or a web component. So what I'm going to do is duplicate this entire block and paste it again. We're going to keep this heading here just so you can divide the 2 lists. Now, if you imagine that we can wrap this entire list node inside a template tag, and we'll indent these accordingly. So the template will then essentially wrap this li, which is why we don't see all these ng4s and all this information in the DOM if you want to inspect element. So what this will basically expand to is an ng4. And the way that it creates this local variable called passenger, it basically does let and then a dash and then passenger. And this will basically be driven from the list of passengers, which we'll explain momentarily. Now we also have the index. So this will do let dash I. So then we need to pass it that index because the index is exposed here via Angular, whereas we're passing our own passengers array in. So the way that we actually do the passengers array is we use this ng4 of. So, and then we just do equal passengers. So that's exactly what's happening when we use this syntax. It treats it as a template element and it creates all this stuff under the hood for you. And this gives you full encapsulation if we want to. We can use Shadow DOM. You can look at how you can use Shadow DOM in the Angular docs on the view encapsulation, and we'll also be covering it in the Angular Pro course on a much more advanced component usage with the view encapsulation. So this essentially is the expanded version of the li ng4 of what Angular's compiler will translate it into. So we'll save this out and then we'll go back to the browser and actually check this out. So you can see here we have airline passengers and the dividing airline passengers, and we have the identical objects in every single one. So hopefully in this lesson you've learned how to iterate a collection of data, which is probably what you'll be doing most in your applications, and by using ng4 and understanding why the syntax is there gives you an understanding of why we're using an asterisk with an ng4 and an ngIf. In this video, we're going to follow on from our airline passengers and we're going to add some styling with Angular. However, we're going to remove the template driven approach and we're just going to stick with our asterisk ng4 because it's much cleaner and much more easier to read. So how do we add some styles dynamically based on whether a passenger is checked in or checked out? So if they're not checked in yet, they're going to have a property of false, like we have 2 that are false, and we have 3 passengers that are checked in. Now for this, I'm just going to use a simple span class. So inside of here, we're going to do span and we'll just close this off. And all we're going to do is create some styles. So for now, we're just going to call this status. So this will be the status that will display a color based on whether they are checked in or checked out. Now to actually do this properly, we will open up our Sass file. So we're actually referencing the Sass file here. So if you want to jump across into here, what we can do below is add a property called status. Now we're going to quickly write some styles. You don't have to do this. However, if you want to follow along, feel free. So all I'm going to do is a width of 10 pixels and a height of 10 pixels and a background. And I'm going to choose a red of C0392B. We're going to use display block. And we're going to use some margin just to actually display this span tag. And we'll do float left. Then we'll give it a nice border radius to make the nice and round. So we'll do 50%. And what we'll do is then, if they are checked in, we will have a class of checked-in. And we're actually going to change the background color to 2ECC and 71. So red will display, as you can see in my VS Code, it's already highlighted the colors for me. If they're checked in, we're going to add a class. If not, then it's going to default to red. So essentially, we're going to add a class. If you've not used Sass before, this ampersand basically means that it's on the same element. So if you've not used Sass, this is basically .status.checkedIn. So it's a chain of classes on the same element. That's all we need for now, so we'll go ahead and save this out. You can close the file, and we'll go and have a look at this in the browser really quickly, just so you can see the initial styles. So by default, we have red circles next to everybody, so nobody is checked in apparently. However, we want to dynamically add these styles with Angular. So let's go and implement this. So this is where things get interesting because there are multiple ways to do this based on your use case. We'll start with the easiest. A property binding, which is going to access the class property. So we want to add a class called checkedIn if the user is checked in. And we're going to do this via a property called passenger.checkedIn. So if this evaluates to true, this checkedIn class is then added. So let's go and check this out. So in the browser, we have green, red, green, green, red. So our classes are now being added correctly because Rose and Tina are not checked in passengers. There are also a few other ways that we can do this, and I'm actually going to copy this entire thing and give you the full source code to each of them. Depending on the approach that you want, such as this might be the best approach because we only want to add a single class name, using class.checkedIn may be a good fit. However, if we wanted to add multiple class names, we can use something called ngClass. So here we have ngClass. Again, we're using that property binding. Now, instead of this passenger.checkedIn, I'm actually going to copy this and then remove it. And we're going to pass in an object. The first property is going to be checked-in. And you can see that this is just an object key. So here we have the opening object. Here is the name of the property. So this will dynamically add a class called checkedIn if the passenger.checkedIn is true. Now you might think, why would we use this instead of another? So let's assume that we could break this onto a new line and we wanted to add another class. So we can actually add a comma and let's assume that we could do checked out and do an inverted expression. We don't actually have any styles for checked out, but what we'll do is have a look at it in the DevTools so we can see that this is actually being added. So when a passenger is not checked in, we'll have a class of checked out, and when they are checked in, we'll have a class of checked in. What we'll do again is grab the H3 just to separate these, and we'll go and check this out in the browser. So in our first list, let's go and inspect the elements. So we can see in here, we have class status and checked in. Now on the next one, we have Rose, who is red, so she is not actually checked in, and you can see that no class has been added. So this is using the first example. The second example is using ngClass. So if we look at Rose here, she will actually have a class of checked out, as you can see right here. And Stephen above will have a class of checked in. So this is basically a way that we can add multiple classes or set up the ability to have multiple classes on a particular element. Earlier in the course, we looked at something called property binding, which is exactly what we're using here. We're binding to a property called ngClass. Now, what we'll do is duplicate this section again, I'm going to show you how to customize some styles. If we don't want to add any class names, what we could do is just eradicate this. So what we can do is use the square brackets. And just like before where we access the class, this underneath will access class name, which is the JavaScript equivalent of this. However, we also have a style object. So you may have done something before in JavaScript that says element.style.background equals, and then perhaps string in red. So this is similar to what we're doing here. So what we can do is actually do background. Now I'm actually going to use the camel case. So this is the JavaScript equivalent. Any properties that you use will need to be JavaScript equivalents. So we're going to use background color here, and all we're going to do is pass in an expression based on whether the passenger has been checked in or not. So we can do passenger.checkedin, and in here we're going to use a ternary, and we'll just set up these quotes really quickly. Now if the passenger is not checked in, we're obviously not going to add this class name because we're not adding anything via a class binding, we're using a style. So what we're going to do is actually set the background color to green. And then otherwise, we're going to set it to red. So we're going to copy those styles across, and we're basically going to create this expression. You don't need to put these, by the way. This just makes the formatting a little bit nicer. So let's go ahead and check this third example out. So you can see here that when we inspect element, we will actually have a background color, and you can see that we've got this RGB, and we can click and we can change it to hexadecimals. So here it's dynamically adding a style and then a background color, and Angular's compiler is doing this for you under the hood. So you can see we have just a single class as status. So no class names are being added here. There's one final way that we can do this with something called ngStyle, which we'll finish off this video with. So let's go ahead and take a look. Again, we're going to copy this and we'll duplicate it below. This one will be a simple refactor. What we'll do is get rid of this. We will copy the background color. We're just going to do ngStyle. And like before, you can probably guess that this is going to be similar to ngClass. This example is going to also use an object, and we're going to use the background color as a key on the object. And then we just need to close off the object on the other side. So all it is an object with a background color property inside. It will evaluate this expression. It will run this ternary statement. If the passenger is checked in, we get the green. If not, we get the red. So let's go and have a look at how ngStyle will paint these to the DOM. So again, we can't see any actual difference in the implementation details, but we have the hexadecimal colors, we have the RGBs, and all four of these are using 4 different approaches to adding styles depending on what you want to achieve. Now, the more you build with Angular, the more you'll be able to understand, and you'll come up with your own approaches to styling based on your requirements. In this lesson, we are going to learn about pipes. Pipes don't need to be complicated. You can think of them as a function that returns you something new. So let's assume that we have a function which takes a string. Now inside this function, because we've called it uppercase, we could do return string dot to uppercase. So when we pass a string into this function, it basically will return it. So we could do var name equals and then uppercase, and we could pass in Todd as a lowercase value. And if we did console.log name, this would then print out Todd. So you can think of a pipe as a data transformation mechanism. So it's pretty much just a function that Angular will run internally for you to do some kind of transformation on a data set or a single value. So here we're just using a single value. However, we've already covered ng4, so you could actually use a pipe on an ng4 as well. So this is just a basic example of how you can use them in JavaScript, or the concept behind them in JavaScript, to start thinking about how we can use pipes. So in our component, what we're going to use is this example with the class.checkedIn, which means that we can remove all the passenger information that we don't want from the previous video. So now if we scroll down, we can see this red underline. This means that we are not conforming to our passenger interface. Now, if we typed it to any, this would mean that we can type anything that we want. However, we want our passenger model to implement this interface. So we can just simply add checked in, which is either a number. So checked in date is going to be a timestamp to a specific date of when the user checked in. So if they are checked in, it's true, and if they are not checked in, they get a null value. So let's go ahead and up to our interface and create checked in date. It's either going to be a number or it's going to be null. And that's simply it. Now I'm assuming that we are actually returning checked in date as null from the server. It might be the case that your API actually does not return it, in which case TypeScript will then complain. In this instance, what you'll want to do is simply remove the null check here and put a question mark here. This makes it an optional property on the interface. So if it doesn't exist, it's absolutely fine. If it does exist, then it must conform to a number. So when we scroll back down, you can see that rows is no longer red. However, when we remove this entire collection becomes red. And if we go back again, we can leave it as number or null, which means when we add the checked in date back in, this then conforms to all of the interfaces for this particular collection. So now that we've adopted our interface, we've done this for a particular reason because we are going to use some pipes against these dates. But what we're going to start with is something called a JSON pipe, which is really helpful for debugging. So this passenger object here, if we wanted to take a closer look, what we could do is create a p tag. Now inside this p tag, we can do passenger and then close this off. Now, instead of passing a function, what we do is create a pipe operator. So you can see this operator here, and all we do is just tell it the name of the pipe here. And all we do is pass in the word JSON. So here we're telling Angular that we want to use the JSON pipe. So we'll go ahead and we'll test this out in the browser just to see what this gives us, because we are looking at the entire passenger object, not just the full name property. So you can see here that we're using the JSON pipe, and instead of object, which is what we saw earlier in one of the videos, we are actually converting our JavaScript object to JSON. So you can see the double quotes here are now valid JSON. Now what we'll do underneath this is actually create a div, and we'll give it a class called date. This is going to resemble when the passenger checked in. Now we are going to say check in date. So what we want to do is do passenger and then check in date. So this will actually give us the checked in date of that particular passenger. So each passenger is a particular date stamp. So Angular thankfully has a date pipe built in, which allows us to specify particular date formats. So for instance, if I just wanted the year, I can type Y. There are various combinations, so if you use a triple M, this will actually give you a short form. So this will essentially give you Sep instead of September, for example. Now, if we wanted it longer and we used 4, this would then just give you September. So check the documentation for all the types of syntaxes. The one that we're going to actually use is similar to this, but we're going to put D on the end, which stands for the day. So you can see that we have our JSON pipe being rendered out with the date timestamp. Now, because we've used a specific format, we're actually using March 29th, 2017. So you can see all the dates that are available have been printed out, and anyone with a red dot doesn't have a date. So we can go back and actually use a ternary expression to basically say that they're not checked in. So let's go ahead and build out another feature. So what we can do to make this a little bit more readable is bump it onto a new line. Now we can check via a ternary expression if the passenger is checked in. So we can do this question mark here. If the passenger is checked in, we can essentially wrap it in a brace like this. Otherwise, what we want to do is just simply put some text saying not checked in. So that's as simple as it gets. That's all we need to do. All we do here is check if it's available. If it's not available, it will actually become null. If the check-in date isn't available, it's going to display this text saying not checked in. Otherwise, it's going to wrap it and it's going to parse the date out for us. So let's save this out and we'll go back to the browser and take a look. So here we are, we can see check-in date March 29th and rows is not checked in, and we have the words not checked in. One really nice feature about pipes is we can actually chain them. So Angular has a built-in pipe called uppercase. So what we can actually do is convert it to a date first, and then it will run the uppercase. If we switch them round, it would convert it to uppercase first, which means that it would actually throw an error because it cannot convert the number, which is a check-in date, to uppercase. So it needs to convert it to a date first, and then it will convert that result to an uppercase format. So we'll go ahead and check this out in the browser as the final demo for this video. And as you can see, for anyone who is checked in, they have an uppercase date. Hopefully this has been a good introduction to Angular pipes. You can check out the documentation on the website for the full list of pipes that are available. But this gives you an example of how to use them in a simple way, such as a JSON pipe. And the JSON pipe is great because it will actually update when you update your data. If we update a property on the passenger, this pipe will then actually update and print out the object in the DOM. So when you're doing debugging, this is actually very useful. We've learned how to create dates. Angular has a very powerful date formatter built in that we can mix and match, we can combine, we could do this and swap them round, and you can essentially compose your own dates. We've also learned how to chain a pipe, and we're again using a complex ternary expression here, just to show a result if the passenger is not checked in. So this gives you an overview of the power of the expressions and the pipes all in one. In this video, we are going to learn about the safe navigation operator. Now, it sounds complicated and it is actually very simple. So the first change that we've made to the source code is we've added this children property. Now you can see this passenger has a child property of null. This passenger, however, has an array of children. Now we're yet to implement an interface of a child, which has a name and an age. So we'll show you how to do this momentarily. And as we scroll down, we have children null, and we also have another child in this array and null in the last one. So what we can do is simply scroll up to the top. And what we can do is create a new interface. So what we're going to do is call this one child. So the child is going to have a name, which is going to be a string, and then it's also going to have an age, which is going to be a number. Now what we can do, instead of assigning this interface somewhere in here, is we can actually add it to our passenger interface. So what we can do is add a new line called children, and we can make this entirely optional. And what we can do is then implement this child interface in a passenger. Now, because it's an array, we need to then declare that it's going to be an array of child objects. Now, instead of making it optional, what we're going to do is just do the same as above, and we're going to make it or null. So all of the passengers below will then comply to the interface. So we have two or nulls here, because we're assuming our API response is going to send back a property, whether it's populated with the objects or not. So in our passenger array, if they comply to the interface, then the children must be of the type child, and it must be an array, otherwise it can just be null. Now we're doing this because we're going to demonstrate the safe navigation operator. Now inside of here, if the child doesn't exist, we can use the safe navigation operator to essentially make sure that Angular doesn't throw an error while it's trying to parse the template. So because we're inside our ng4, we have access to this passenger. And now the passengers have a .children property. Now this is an array. So we don't want to display the names or the ages of the children. However, we want to display the length of the children. So when we save this and actually go to the browser, we'll see something interesting. So you can see here that we've got a few items rendered and then two red dots. So something has clearly gone wrong. So if we open up the Chrome DevTools, it says cannot read property length of null. This is because that particular passenger does not have a child, therefore the null property does not have a length. So this is where the safe navigation operator comes into play. Now where it's erroring is on this length. Now if we remove this, this will simply display the actual objects in the DOM, otherwise it will display the word null. So because we want to use the length, we can use the safe navigation operator to basically say, if this exists, then continue to the next step. And all we need to do here is actually put a question mark, and that's all we need to do. So this basically will evaluate this expression here. It will then check if it's available using the safe navigation and then continue with the expression. So when we go back to the browser, we'll actually see a list of children or no children. So you can see that children 2, children has nothing next to it, children has nothing next to it, and our fourth passenger has children 1, and the fifth one is empty. So what we can do, because we can use an Angular expression, this is just like JavaScript, we can use the OR operator, and we can just say 0. So if it doesn't have the length, we can just say 0. And when we go back to the browser, you can see children 0, 2, 0, 1, and 0. Now, if this passenger had some information updated and it actually had an item pushed into the children array, this would then update to reflect the bindings. So as soon as Angular makes the data change, we can see this state change. So using the safe navigation operator allows us to essentially safety check our object properties before they're parsed. So if the children.length exists, then it will evaluate the expression like we see here with 2. Otherwise, it will just continue to our OR statement. Now you don't have to use an OR statement, but it fits in nicely with this demo where we have children 0, 2, 3, 0, 1, 0. The safe navigation operator also comes in handy when we're passing data down into components, which we'll come on to soon, because at times our data won't be statically coded. So we'll be making asynchronous data requests, and we can use the safe navigation operator as that request is happening to actually check if the property is available or not. When the property becomes available, Angular will then continue evaluating the expression.